Alright guys, we're back. This is again Check for Understanding number 9, topic 4. This was the second one that popped up for me when I was completing the assignment. So this is the one we're going to do. There are a couple of things that I want to bring to your attention. This purple asterisk we'll get to later. And right here on the second circle, we have circle D. We're going to go ahead and cross out, or if you'll go ahead and cross out, if you're working on your own notebook paper, this is not 14/9 pi. I mean, it actually is, but we're going to, that's in radians, and we're not going to worry about radians right now. Go ahead and change it to 280 degrees. Okay, so that will help you. So again, we're going to analyze, consider the two congruent circles below. Here we go. Let's consider them. We have circle A and circle D. Select all the statements that are true. And as I start glancing through, I think I see that all of this has to do with area. So I'm going to put a little reminder up here that the area of a circle is equal to pi r squared. And I'm going to rewrite that as r squared pi. You don't have to do that. You know me, I just like to have that radius first. So let's go ahead and analyze each of these. We're going to start with circle A. And I want to go ahead and fill in my area wherever I can. I know that the whole circle measures 360 degrees. That's a fact for both circles. And I look here and I have this gray portion, which is 80 degrees. This angle part is 80 degrees. So we're going to go ahead and subtract 80 from 360. And I end up with 280 degrees. I'm going to write a little reminder here in my circle. And then I'm going to come over here and I look and it says the two circles are congruent. And this is 280 and this is 280. So since these two are the same, this is 80, this has to be 80. But what if my math was wrong? Let's do the math over here. 360 minus 280 gives me 80. That's just a little double check. It took me 10 seconds to write that, and my hand's not even tired. So I filled that in. All my circle is filled in. Let's see if we can start looking. I could go ahead and do the math. I could find the area of sector CB and sector FE. I could do that. But the more I analyze the pictures, the more I see that, hey, wait a minute, I don't have to do that. The two angles are congruent, and this radius is congruent to this radius. So since the angles are congruent and the radii are congruent, then I know the area is going to be congruent. So I'm going to go ahead and mark this off as true. We're not going to worry about this purple one right now. We'll come back to it last after we do the others. Alright, so this next question is asking me that if the area of FGE is added to the area of CB, then I will get the area of circle A. So I look and I'm like, okay. I know that CB, the area of CB, is congruent to the area of FE, so just by substitution, I don't have to do the math. I could say area sector FE, FGE plus arc FE. Does that give me the whole circle D? Yes. Does it tell me these two circles are congruent? Yes. Therefore, this is true. I didn't even have to do any math. Now, when we get up to this choice, we're going to have to do a little bit of math. Okay? They want us to find the area of FGE, which I've already written out, and I don't have room right here to write it, so well, I'll just write it down here for you. I know that the measurement of angle FGE is equal to 280 degrees. So what I need to do right now is go ahead and we're going to deal with, remember when we've talked about part to whole, and we've talked about that a million times in different concepts. So right now we're going to be dealing with part to whole. I'm color coding for you. And we're going to deal with degrees first. So I'm going to look at my little triangle, or my circle over here, and the measurement in degrees for that FGE is 280. Underneath, I'm going to write the whole, and we know the whole is 360. Every circle measures 360 degrees. Okay. We want to compare that to our area. Okay, we have not yet found the area of these two circles, so we're going to come back up here and we're going to do that. We know here that the area of a circle is pi r squared, or r squared pi. I look over here, and what is my radius? It is 6. And 6 squared is 36. So my area of both circles is 36 pi. So I'm going to come down here and put 36 pi on the bottom. And what is my top going to be? How do I know the area of this set? I don't know that yet. That's the thing I don't know. So let's put in an X. Okay. And now we've kind of got ourselves a little ratio going on. Well, we've got two ratios which make a proportion, so we have two ratios that have to be in proportion to each other. And we're going to go ahead and use cross multiplication to simplify that and solve for X. So I end up with 280 times 36 pi equal to 360x. And I didn't think this through when I was writing because I always like my x's on the left, but we'll deal with that later. So we're going to go ahead and do the math. I am not going to simplify that pi yet. I know they have the answer in terms of a decimal, but I want to do that at the very end. So let's go ahead and clear out from yesterday, and we have 280 times 36, and that gives me 1008. Now I could have simplified that fraction first, but I didn't, so we're just going to go with it. 1080 pi is equal to okay, so next I need to get rid of that 360. What am I going to do? Go back up here, divide by 360, and we get 28. That was nice. Nice, nice, nice. 28 pi equals x. So the area of this section is 28 pi. Well, they didn't give me anything in terms of pi, so now I'm going to go ahead and plug in. I can either use 3.14 or I can use my pi symbol. And sometimes that pi symbol might be hard to locate, so I'm going to let you do, you can choose.